Hey guys, welcome to this next video video series on the Himalayan saltwater battery. So as you can see, I have two here in series, and believe it or not, this one is built much better. I have a zinc steel mixed bolt that's going from the top here all the way to the inside of the bottom. And I just have it wrapped in cloth, and I'm starting to realize that it's pressure that makes these batteries work so well. If the cloth is pressurized to the bolt or the cathode of the battery, it seems to hold the amperage for a lot longer, and it makes it work like an actual battery. If you look up Aqueon, you will have a better understanding of how maybe the battery works, but I figured being able to demonstrate it live like this would be an easier way to do it. So when I charge these batteries, I can also charge them in series. This battery can put off 0.8 of a volt, and this battery puts off roughly 0.7, 0.8 of a volt as well. So you stack it in series, and you have 1.6 of a volt. And mind you, this motor that I have spinning right here is not plugged in. And you guys will see me plug it in here in just a moment. And just to prove to you that the batteries are actually powering it, what I'm going to demonstrate is to show you there's no secret battery in my motor. I'm just going to have this unhooked, and then I'll hook it back up to demonstrate that it completes the circuit. And I think that proves that I'm not pulling any tricks. If you watch any other saltwater battery videos, you'd completely understand. So, 1 second. Alright, so I just made sure my leads were hooked properly. Now we're just going to plug this in. Oh, there we go. Oh my gosh. Hold on. Alright, so I have the worst outlets in the world. It's one of those kind of outlets where you plug it in and you're not sure if the plug is even going to hold inside of the female hole. Yeah. So anyways, I have this spinning at top speed, 5 volts at 1 amp right now. It is also charging my battery, both of these batteries in series should be putting off about 1.5, 1.6 of a volt. And you'll see it working its magic over here. I need a better quality camera though, which is unfortunate. I can't get a better close-up HD view of how this battery works, but it looks like it starts vacuuming a whole bunch of the water up through the spring here, like some sort of super induction effect from the amperage. And I'm wondering if it's because of the pressure of the spring affecting it in one way, shape, or form. Alright, so I'm going to unplug the motor, or unplug the charger, and you're going to see how long this thing powers for. I'll watch the motor, and you'll be able to see that it does not lose speed very fast. The batteries seem to hold charge for a very long time. And it doesn't seem to be slowing down very fast. Actually, it's not slowing down at all. It just slowed down to what seems to be a voltage rating that I would think would be equivalent to about 1.3, 1.4 volts. And I just had it on the charger for, a minute? So, as you can tell, this is groundbreaking. This battery right here only uses 1/4 of a tablespoon Himalayan salt. So I think this could solve a lot of our problems with the energy crisis we have now, besides the other options, which is solar power and geothermal power and wind energy. But this could solve our problem with recycling pop cans as well. Just something to toss in there. And iron bolts are very easy to find. Or not iron, but steel bolts. I don't really know any other ways to break this down, guys. You can just check it out for yourself. Let me know what you think. If you want me to build a even bigger rechargeable saltwater battery pack, please comment, like, and subscribe to this video, because I would love to make some bigger and better ones, and I'd love to be able to get a camera and start demonstrating these batteries on a large scale so I can prove to you all that at least storable energy is very easy to achieve using nothing but salt water. Let me know what you think, guys. Just to save you a lot of time watching this thing power, this motor spins just about, it spins as long, if not longer, than what I have it on the charge for. So hence, that's the reason why I think this battery idea would be perfect for solar power. When people are gone at work all day, it could charge the batteries all day, and then they'd have power all night. So let me know what you guys think. Peace.